Well, hi everyone. Actually, I'm going to start now. Actually, last lecture, the main heading we were talking about under the physical environment, basically climate and weather. And we talked a little bit about, in this regard, we talked a little bit about the atmosphere. We talk about the troposphere, the stratosphere, and we finished the stratosphere. I'm going to start now with the mesosphere. And basically, as already I showed you here, these are the layer in which basically we are, okay? Talk about. So now we're going to talk about basically about the mesosphere, okay, which is basically in this area here. Okay, now mention this one here. Now, the mesosphere extend. Just put down here. Just give me a second. Okay. Called the mesosphere. Okay, extends, okay, beyond the stratosphere. Okay, beyond the stratosphere to about 75 kilometers. Okay, kilometer now. Then we have the other one here, the thermosphere. Okay, extends to about 450 kilometers, okay, or more. Okay. Now, beyond the atmosphere, just to make sure that you see this one here, beyond the atmosphere, okay, is the outer space. Okay, is the outer space basically where a region, okay, where the Earth's atmosphere okay, where the Earth's atmosphere, okay, exerts no detectable chemical or thermal influences. Or thermal influences. Okay. And now we're going to talk about basically the what are the constituent of the mass of the atmosphere. Now, about 78 of the mass of the atmosphere about 78%, okay, of the mass of the atmosphere okay, the mass of the atmosphere. Okay, is nitrogen gas. Okay, which is basically M2. Okay, while we have, okay, 21% is oxygen. Okay, two. Excuse me. And 0.9% argon gas, and 0.08%, which is carbon dioxide. Okay. Now, after this, basically, the rest, of course, is various trace gases. Okay. The rest is a trace various gases, basically, including potentially toxic chemical. Including potentially toxic chemicals. Okay. This point here, such as ozone, which is O3, okay, and sulfur dioxide, okay, which is basically O2. Now, also to mention, basically, the atmosphere also contain okay, also contain or contains basically highly variable concentration. Okay. Okay. Concentrations of water vapor, okay, which basically which can range, okay, from only, okay, 0.01% in a frigid winter, okay, frigid winter, air in the Arctic, okay, to almost range to 5% in warm, humid tropical air. Okay. Now to talk about the basically more or less about how much pressure it has, what you call the total weight of the atmosphere as an average here. Now, on average, okay, the total weight of Earth's atmosphere, okay, mass, okay, basically exerts a pressure okay, exert a pressure at, of course, you take it at the sea level, okay, of around, okay, 1 times 10 to power 5, we call it, okay, which goes as Pascal here, PA, the unit, which basically, or simply we call it, or 1 atmosphere. This is equal to 1 atmosphere, okay, which is simply equivalent okay, of the weight of 1 kilogram mass per square centimeter. Okay, however, this of course, it could be variable, just to mention this point here. Now, however, okay, mentioning that air pressure, okay, of course, however, this is basically variable, okay, over space and time. Okay. So now basically we want to talk about what you call, what is known as climate and weather. Okay. Now, simply going to mention, of course, you may know this, but at least to mention it here, that basically climate, okay, refers to the prevailing okay, to the prevailing atmospheric conditions conditions, of course, as you know, of temperature, okay, precipitation, okay, humidity, wind speed, okay, and direction. and direction. Okay. Now these basically the wind speed and direction, normally we give it as basically together known as the wind velocity. Okay, together the wind, okay, velocity. Then the other thing was they talk about called isolation. Okay, which is basically, that means, I'm going to put it down here. I think you just give me a second. Okay, which include basically the incoming solar radiation. Okay, and also we talk about visibility. Okay, the fog, all that. Okay, just give me a second here. Okay. Here, I guess. Did you see this one here? Visibility, fog. Okay, and also cloud cover in a place or a region. All that. Or basically, or region. So basically, that basically, in other words, the definition or what we mean by basically when you talk about climate here. Okay. Now the other point still I'm talking about the climate, that climatic data okay, are usually calculated okay, are usually calculated basically as statistics. Okay, such as, for example, average or range or ranges of values. Okay. And basically, of course, they use this for over 10 or 20 years. I think hopefully later on, maybe have time, then I'll give you an example of these data, because that we've collected the data of the climate. Okay, to mention this point here, using data or data, okay, obtained okay, from several decades. Okay, from several decades or more of monitoring. Of monitoring. And now usually to mention one point, usually going to, because usually to have the perfect data about the climate for an area, really, it have to be collected over a period of 30 years. Going to mention this point for you here. Now, the perfect period, okay, for the calculation, okay, for the calculation of normal, we call it of uh, normal climatic parameters, okay, is at least 30 years. Okay. Now, basically, this is okay. Now, this everybody finished from this one here? Okay, then I'm going to move it. Somebody won't just let me ask me. Okay, now, of course, to talk about weather, okay, in contrast, okay, weather basically refers to relatively, okay, short term, okay, for example, day to day, okay, or instantaneous meteorological or instantaneous or instantaneous, okay, meteorological conditions. Okay, the conditions. Now, to mention this point here, and because, of course, your weather, sorry, is related to a short-term condition, okay, to a short-term conditions, okay. In that case, it is much more variable. Okay, it is much more variable over time and space. Okay, over time and space than climate. Okay. Now to mention, of course, this point, basically what is the climate itself, basically, okay, to mention this point here. Now, many aspects of Earth's climate, okay, many aspects of Earth's climate, simply to mention, of course, are functions okay, of solar installations, and of course, and of how this. Okay, incoming energy, okay, is absorbed, okay, reflected, and re-radiated, or radiated, okay, radiated by the atmosphere. Okay, by the atmosphere, oceans, okay, and terrestrial surfaces. Okay. And here I'm going to mention, of course, there are about 3 or 4 other important factors which is important to do this, what you call ecological phenomena on the Earth, to mention this point here. Now, however, okay, there are several ecological aspects. Okay, important, of course, in one or another, of course, in shaping the climate or the Earth climate. Okay, I'm going to talk about some of these here. The one I'm going to talk about, of course, is important, of course, what you have here, that the factors I'm going to talk about the sun itself, a little bit, the impact of that. The other factor I'm going to talk about, basically, atmospheric reflection and absorption. The other factor, which is basically the cycle, we have the night and day. Okay. And the other thing I want to talk about a little bit here.
What you're writing.
Is it okay now?
Yes, thank you.
It's okay, thank you. Okay. All right. And the other thing we call, basically we call, okay. Okay, these things here. I want to talk about each one a little bit in a very short, what you call, the night and day. There are other factors, but I don't have time to talk all about this one here, okay? The other one, of course, is effects of latitude. Okay, the other one is, of course, the seasons. Okay. Then we have aspect and slopes, or slope. Okay. The other factor is important, called soil and vegetation cover. Okay. The other aspect here snow and ice cover. Okay. And then we have, of course, evaporation of water. So basically, these are the thing I want to talk a little bit about it, not very much here because it's very long here now. Now, of course, the sun, as you know, is very important because already we mentioned, of course, in the Earth itself, it has what they call the core of the Earth, which has the heat, but of course, that's not enough to give us the heat we require. And just to mention that if we don't have the sun, how is going to be the temperature of the Earth? Now, just one thing to mention, of course, about the sun here, just take it in a very short period here. Now, if it were not for the warming influence of solar radiation, okay, if it were okay, warming influence of solar radiation, the temperature of the Earth, okay, of Earth, okay, surface and atmosphere, okay, would okay, would approach okay, what is known as approach the coldest that is okay, the coldest that is, as a matter of fact, what you call physically possible. Okay, physically possible, which is basically the value known as absolute zero. Okay, when I say, but this is zero, of course, as you know, the zero as 0 degrees Celsius. No, so known as possible. This one as absolute zero, which is simply, which is, or it is equal, according to the Celsius, minus 273 degrees Celsius. That is known as absolute zero. So without the sun, that would happen here. Of course, you know, the Earth, of course, it has what you call generating its own heat, but of course that is very limited, as we say, from the decaying of the radioactive material and other thing in the core of the Earth. Now, to mention about this point here. Okay, give me a second to take it out here. Okay. All right. Now, the other thing I want to mention here, I guess, is, okay, see this one here, is the atmospheric reflection and absorption, because all this is important for us to understand later on some of these gases and so on, how they work. Called atmospheric reflection and absorption. Okay, and this is the other factor we talk about here now. Now, the condition, for example, uh, okay, for instance, they have a lot of impact, of course. For instance, for example, cloud cover, okay, and the tiny called particulates, called tiny particulates. These are basically are highly reflective. Okay, are highly reflective of many visibles, of many visible, as a matter of fact here, wavelengths. Of many visible wavelengths, okay, of course, of incoming solar radiation. Of incoming solar radiation, okay. And also in this case, of course, they have in that case, they have what is known as some cooling effect, and to mention this point, okay, and so have a cooling effect. Okay, cooling effect. What do you call on the lower atmosphere and the surface. Okay, in the lower atmosphere and the surface. Okay. Now, of course, in addition to this, that to mention there are other things contained like trace information that have also affect. Now, to mention, in addition, of course, the atmosphere contain okay, contains okay, what you call a trace concentration. This is not a trace concentrations. Okay, trace concentration of gases, of course, that absorb okay, some of the infrared radiation. Okay. If you finish from this one here, I'm going to take it out now. Of infrared radiation. Okay. That the planet okay emits basically to cool itself. Okay, to cool itself of the heat okay, of the heat that absorb, sorry, of the heat okay, obtained okay, from solar radiation. Okay. Now, basically, of course, you have some of these are very important to mention. What are the most important of these? What you call the trace, what you call gases concentration. Talk about it now. Most important, and okay, to mention this point here, that most important, I would say in this regard, okay, one of them is very important. This regard basically are water vapor, okay, or water vapor, okay, carbon dioxide, okay, and methane. Okay, and methane. And of course, this is important to know because these guys, of course, they have it also, we call these guys, as a matter of fact, also known as greenhouse gases because of the impact they do of the heating. And to mention this point here, okay? Now to mention here now, because, okay, of the influence okay, of these, the last one I mentioned of these is this so-called, okay, greenhouse gases. These are called the greenhouse gases, okay, and that's basically they maintain what you call that the temperature of the air in some range. Going to measure, okay, okay, greenhouse gases. Now, basically, what happened here that Earth surface, okay, Earth surface temperature, okay, is maintained okay at an average okay at an average of about okay an average of about basically 15 degrees Celsius to 33 degrees Celsius, okay, warmer than was supposed to be than the minus 18 degrees Celsius, that basically without the effect of these moderating gases. Okay, so basically, as you can see here, that make it at 15 to 33 degrees less than this temperature, which is supposed to be that you call, if it happens, there is no moderation of these gases. To mention this one here, would okay, it would be okay without okay, I mentioned without the moderating effect okay without the of these what you call yeah of these factors. I mentioned the factor here basically what you call the carbon dioxide, water vapor, and methane. Okay. And now basically I'm just going to a little bit here about the other factor we mentioned, night and day. Okay. Of course, the night day is going to give that change in the energy. So I'm going just to summarize in this way to mention this point here that the daily 24-hour hour, which is basically, as you know, known as the diurnal. Known as the diurnal variation. Okay, or variations in energy input. Okay, result simply. Okay. In a large change in weather. Okay, in weather. And of course, to make this point, and this basically affects, and this affects, okay, greatly, or this effect varies greatly between tropical and polar latitude, of course. And polar latitudes, okay? Now, as already you know, going to mention it here, as already you know, the basically that the tropical regions okay, tropical regions, as already you know, have approximately okay, equal day, okay, and night length, okay, of the night lengths, okay, of about basically 12 hours each. Okay, as already you know that. Okay, while for example, polar, in that case, latitudes, as already you know, simply are much, we call it seasonal. Okay. Yeah, because that basically gives us an idea about the, okay, let's see it here. Yeah. These are basically, although they are basically, I mentioned many other factors, but I am just focusing on these three, which has the most, because especially of the guys and other we're going to talk about here. Now, once we finish with this one here, then I'm going to move basically the other thing to give us a background in studying what's happening, basically all that impact of the environment, including, of course, all the pollution, everything. Basically, with regard how the energy works, because we have to understand this phenomenon here. Okay. So now I'm going to start with you now. As a new title here, basically talk about that simply called energy and ecosystem. Was now to make in this regard here, basically Earth's ecosystem in general, okay, Earth's ecosystems are not closed. Okay, they are not closed or self-sustaining system. Okay, in fact, as was what we were talking about earlier, in fact, without continuous access, without continuous access to an external source of energy, okay, ecosystems okay, would quickly deplete. Okay. Okay, would quickly, as a matter of fact, okay, deplete, okay, their quantities okay, their quantities of stored energy. Okay, of stored energy, and of course, as a result of that, okay, and cease to function. Okay, and cease to function. Now, I think I will going to continue here under this line here as a matter of fact, of course, as you know. Now, as already mentioned, that the external source of energy okay, is of course is the solar energy. Okay, which is stored, okay, which is stored mainly This is mainly, I guess. Okay. Put that here. Just give me a second here, just to take it down. Okay. Sorry about that. All right. Stored mainly, of course, as a biomass and heat, which is stored mainly as a biomass and heat. Okay. Which is already, simply to make it that, of course, without the solar energy, as already explained before in different way. Okay. Now we're going to talk about what you call the nature of energy. Okay. Now, simply, of course, going to mention in this regard here that energy is a fundamental physical entity. Energy, okay, is a fundamental okay, physical entity, okay, and is okay, and is defined simply simply as the capacity as the capacity of a body or system simply, of course, to accomplish a work. To accomplish work. Okay. The other going to mention in this regard, as you already may know, that energy, for example, can exist in various states. Okay, in various states, and each of which as a matter of fact, is fundamentally different. Did you finish on this one here, please? Okay, I'm going to move it now, just in case. Let me know. Okay. And each of which, as a matter of fact, fundamentally different from the other, which is different, from the other. Now, to mention, but of course, under suitable conditions, conditions, however, of course, this is would be any energy, state, can be converted into another. okay, into another, okay, through various physical or chemical transformation, into another, through various, okay, various physical or chemical, oh, sorry, this one here, or chemical, a transformation, transformation, okay. Now, as you know, however, the states can be grouped, means the energy of this of the energy, the states of this energy, okay, uh, can be grouped, okay, into three categories. Of energy, okay, which basically we have the electromagnetic, see, and we have kinetic, okay, and you have, of course, potential, okay. Let me show you this one here. Okay, what it's saying. Okay. Now I'm going to start first with the electromagnetic. Sorry, this electromagnetic. Okay. Or in other words, also we call it electromagnetic radiation. Electromagnetic radiation, okay, basically is associated, this energy is associated, okay, with photons. So simply sometimes we just like this one here, okay. Simply, this is, of course, really, if you look at what is the electromagnetic energy, okay, it's kind of photon. I'm going to talk about a little bit here, okay. Okay. That it's the photon-based entity, okay, of both, okay, particles, okay, and waves. And that's what I showed to you here. And waves that travel, okay, through space, through space at a constant speed. Okay, at constant speed. Okay, of basically of 3 times 10 to the power 8. Okay, it's basically miles per second. Or simply this is, as a matter of fact, in other words, the speed of light. Now to explain a little bit of this one here now. Electromagnetic energy. Okay, exists. Okay, in a continuous spectrum. Good. In a continuous spectrum, of course, I showed you. Okay, of wavelengths. Okay, of wavelengths. Okay, which is, as already we know, which are known. Okay, as gamma. Or X-ray. Or ultraviolet. Okay, or also known as visible light. Infrared. Sorry. Infrared. Or as microwaves or microwave. Okay. And also as what you call as radio wavelengths and radio. Okay. To mention, of course, basically that the human eye, okay, can perceive sorry, can perceive what you call the electromagnetic energy. Okay, with wavelengths okay of about okay 0.4 to 0.7 ultra microwave here, the range which we call it what you call the visible light. Okay, a range okay commonly referred to commonly referred to. Okay.